Hi, I just wanted to do a quick video about the presentation that we did for our club general interest meeting, the ABC Decentralized. And I know some of you didn't make it and you wanted, I didn't record the audio, I just have the slides, so I just wanted to kind of talk along with some of the slides if you guys are interested in seeing that. So I'm going to share my screen here. And I'm going to run through briefly what we went through. So our club is called ABC Decentralized. And I think officially we still need to change the main name, but what that stands for is all blockchain, cryptocurrency, and decentralized technologies. So if you're interested, join. I know a lot of you said you want to be added to the email list. I assume that means you want to join the club. This club is for technologists and non-technologists alike. You don't have to be super familiar with C++, Java, Python, or anything. If you just are interested in the technology, you want to get more familiar with the lingo, you want to network with those that are well known in the blockchain community, this is a perfect place to join because Professor Evans has a lot of those connections. I know a few people as well, so this is a great way for us to all be able to network with each other. And joining the club gives you access to Zoom speakers from the blockchain and law class that Professor Evans runs. So that's a great thing. I'll be sending out that list later. You guys can let Professor Evans know if you want to join the class, and you just call in through a Zoom call and you can listen to some excellent speakers. And I'm going to go over who some of those speakers are in a second. It's a great opportunity for you to become more well-versed with the blockchain lingo. And you're going to be hearing a lot of different terms all the time. People hear things like decentralized, proof of work, proof of stake, but they have no idea what it's talking about. So hopefully these meetings get you more familiar with those terms and you can strike real conversations with those blockchain industry experts, consultants, and other lawyers. And also something that I am in the process of announcing, but there should be lots of opportunities to write blog posts regarding blockchain and the law. There's some law firms that I've reached out to that are interested in us participating and collaborating with writing blog posts. And of course, even us as a club individually, we will want to get going on that and starting to write some blog things. There's a lot of opportunities to volunteer, so let me know if you're interested in doing more, and we can definitely get into that. So some of those Zoom calls, they'll include speakers like Renee Bostick from IBM, Hester Pierce, the SEC commissioner, Caitlin Long, Wyoming Blockchain, and many other people. I'm even in correspondence with the Overstock CEO and Carl Youngblood, another blockchain advisor and speaker, as well as Tamika Tillerman. So these are all people that hopefully within the next couple semesters, at least, you'll be able to see a lot of prominent blockchain speakers. So what we talked about in our meeting on Thursday, Logan and I went over some important words in this space. What are some important lingo terms? And then Professor Evans went over why lawyers should care about the blockchain. That's a separate presentation. I will attach the PDF of her presentation once I get it from her, as well as her audio recording, so you can listen to that if you want to. Since Logan is not here, he kind of did the first few slides, but they were just very high-level overviews of what blockchain is. So like block collection of data, right? He talks about the blockchain, makes an analogies to how it's kind of like a Google spreadsheet. Everyone can edit it, everyone has a copy of it. And these are some general concepts here. I will be digging more into this, and you can watch this video if you want. It's just about some dude that basically loses his private key, so he can't access his Bitcoin, and it's worth like 67 million now. And it's ironic, but he's joking that he's not really joking, but he's saying this is the most secure thing ever. I can't even get back my own money. So pretty funny, but kind of illustrates some of the problems in cryptocurrency and some of the pros to just being such a high security system. And then he talked about smart contracts. Now this is where I started to kind of talk more, and I think an important thing of being familiar with the blockchain world is first just having this paradigm in mind: decentralized versus centralized. Now, in the blockchain world, when we use the term centralized, what we're talking about is a system that is concentrated in its control. It's focused. It's a single authority and it's top down. So think of a corporation. There's a CEO that makes a decision, implements some type of policy, and it flows down throughout the hierarchy of the corporation. And there's upsides and downsides to big centralized repositories like this, or centralized organizations, right? It's very stable. You know what to expect. You know that it's stable. It's not going to crumble or fall really fast, but it's also rigid in adapting to changes. And a lot of people know this. This is kind of just like a common meme in our minds is, the bigger the federal government is, the bigger the corporation is, the little cogs in the machine, the little workers, they don't feel like they're doing anything. They're like, well, do I really care what I do at work? Because any type of change I try to suggest, no one's going to listen anyways, right? And then there's more of this concept of decentralized, where power, authority is distributed. And this doesn't necessarily just focus on power. It could be processes, functions, etc. But this is a bottom-up control. So think of more grassroots movements. Think of like open source software. Think of all these different things, how they're more spontaneous and somewhat unpredictable. And maybe some downsides are that it's less stable, right? These things aren't as coordinated. It can't happen as quickly in some respects. But in some respects, the changes that are necessary happen a lot quicker than centralized systems. So with that paradigm in mind, we can look at some of these examples here. So this is, A is just kind of an example of centralization. B is inclined towards more decentralization. So examples of centralization are federal governments, large corporations, military, banks, while examples of decentralized systems, internet, more on that side anyways, open source software, peer-to-peer, Wikipedia, in the sense that everyone's contributing to different articles and it's outsourced that way. Human neural networks. So our brains are actually quite decentralized in the sense that if a circuitry gets destroyed, gets damaged by trauma or some type of other accident, there is good evidence that suggests that our brains are plastic, meaning that it can rewire itself and we can relearn certain functions when we lose vital neurons. So just because you're knocking out some vital circuitry doesn't mean that it's going to completely destroy all the systems of the brain. So I was reading the other day in a blog post by the founder of Ethereum, that's Vitalik Buterin, and he had a wonderful blog post. If you want to look it up, it's called The Meaning of Decentralization. He talks about how often our paradigm of simple decentralization versus centralization is probably too simple. And what we should think of when we're talking about this paradigm of centralization versus decentralization is we should layer it. There should be 3 different layers. The first one he mentions is architectural decentralization. And what that's talking about is, by design, how is the system composed? How many physical computers is this system made of? If I destroy any one computer, part of this system will destroy the whole network, right? So maybe for Facebook, let's say, for example, they only have one server in California. If hackers successfully manage to attack the server and take it down, the Facebook network is down, right? But for other peer-to-peer software systems, you can take down one server, but the network can still survive. So this is more of the concept of architectural. Political now is posing the question of how many individuals, organizations, entities ultimately control the computers that the system is made up of. So, the federal government, of course, is political centralization. Now, logical, this is talking about the interface and the data structure. So does it act as a single monolithic object with a agreed upon state, or is it more of like an amorphous swamp, right? Can you cut this thing in half and it would still function fine because there's not really any form to it? Or because there's an agreed upon state, once you destroy it in half, right, it's not going to be able to function logically because they all have an agreed upon state in which they're functioning on. So this is kind of a keep in mind what you had before of this centralization versus decentralization paradigm, and we're layering it now. We're saying, yes, that model is true, but what we can say is, let's look at it a little deeper. Let's look at architecturally, politically, and logically. So let's start with a big one, Bitcoin. You guys have all probably heard of Bitcoin. You've heard of it probably with the Silk Road, buying cocaine, meth, any contraband, right? And these are, I would argue technically all myths, and I think the facts would and the stats would back that up, but that's for another discussion. But Bitcoin, I want to kind of start to dive into this, excuse me, and help you understand to some respects how it works. And this is really just scraping the surface. So for those that are very technical, forgive me if I'm not diving into the weeds deep enough, but I don't want anyone to get lost here, so we're just getting started. Let's start with Bitcoin. To give you kind of a background overview, Bitcoin was created in 2009. A lot of people think that it was in response to the financial housing bubble and those things. It was created under the pseudonym of Satoshi Nakamoto. Now, is that a person? Is it a group of people? Who knows? He hasn't revealed himself, or she hasn't revealed herself, and they don't care to do that. It was released to the public by an open source code. The source code as an open source software, so anyone can view it. You can build off it. You can make a different type of blockchain if you want. There's so many different possibilities. And it seems to be that the intention of Bitcoin as a cryptocurrency was to reduce the number of middlemen, so banks, right, as much as possible. And it did this not just as an electronic payment system, but one that could eliminate something that we call the double spend problem. So I'm going to get into that in a second, but the double spend problem is basically, if you think of music, we have music files. It's quite easy to duplicate, to inflate these music files and send them to your friends, to your family, and you still have the same files, right? So this is really a problem that's been around since the 70s, the 80s, whenever they started kind of thinking about this electronic cash. That has persisted, is how do we stop people from double spending their money, from inflating, from counterfeiting the money supply, right? So think back to that model we talked about. We have decentralization, centralization, and then architecturally, politically, and logically. Now, applying Buderick's model to Bitcoin, this is what we have. Bitcoin is politically decentralized. No person or organization controls the network. Architecturally, it is also decentralized. The design of the network is to be composed of many different nodes that join the network, and destroying a node does not affect the network. But logically, it is centralized in the sense that Bitcoin network acts as a single computer, and there's agreed upon state. So many people will say, well, cool, that's great that Bitcoin's trying to solve this problem of getting rid of middlemen, but traditional payment methods really, they work quite well. I use my Visa card all the time. I use Venmo, and these are great systems to be able to pay each other very quickly. And you're right, they are in place for a reason. And what traditional payment methods are in place for, in one sense, for electronic cash at least, is to reduce the double spend problem. They know it's easy to duplicate it, so there are these middlemen that are there to check to make sure that people aren't spending their money twice. Traditional payment methods are trusted, they have the assurance of the public, and they're well tested. They've been around for many, 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 many generations. So to kind of illustrate this double spend problem, let's say I am A, and I am sending money to B, but I'm also duplicating, inflating that money and sending it to C. And I'm trying to trick the network, and maybe I don't broadcast to everyone that I'm sending it to B, but I broadcast to everyone that I'm sending to C. So essentially, I have $5, but I'm making that $10, and it's just benefiting me, right? So what is in place now is right in the middle of it, we have our banks, we have our other payment system middlemen that are there to check our encryption keys, check our private and public keys to make sure that we're not spending those things twice. So they're saying, no, you can't send that $5 there. So that's great and all, but how does Bitcoin solve this problem of making sure that we're not able to transmit money the same type of money multiple times and inflate the money supply. Now, to understand that, I want to go over two quite complicated topics, but I'm going to just water it down as much as possible to understand how it solves this double spend problem. And that's hashes and Merkle trees. So a hash, let's think of this hash as a transaction that happens, right? Me sending money to Jim in Singapore. I'm sending him $5. So each transaction has a hash ID that goes with it, right? So look at this here. This is hello, I'm Bob. And hello, I'm Bob. Once we hash this, it's a one-way output function. And it gives us this digit here, this ID, 145789. On the contrary, if I change that 3 to an E, hello, I'm Bob, but it's changed one character, it has a completely different output ID. And just keep in mind, it's very difficult. It's computationally very difficult to move from here backwards. So to get from 145789 to hello, I'm Bob, computationally technically impossible. Like, that's a very difficult problem to solve. But it makes it so we have these transaction IDs and they're hashed and they give us these specific IDs. So think of hashes as separate transactions. And what we're doing is so there's so many different people transacting in the world. And then there's these miners that they're grabbing these different transactions and they're compiling them into blocks of data. And in this process, they're creating a top hash. So each block of data contains a hash ID. This Merkle root is what we would call it. And that Merkle root is based off of all of the other hashes that are put together into this block to form the Merkle root. So if we look at a blockchain, right, so there's these blocks of data that are chained together. Really, just think of each block as composed of a Merkle tree. So right down here, you see my transactions going into this Merkle tree. There's other people's transactions going in. There's a top Merkle root formed, which is put into the block, and it forms the header of the block. And the next block that is formed is also dependent on that. Okay, so let's have a hypothetical here. We have a whole chain of blocks going from 1 to 4 here, right? 1, 2, 3, 4. And of course, there's a genesis block. That's the beginning block. And with my transaction, so I transact $5 to Bob. And my hash ID is 11567. And that's created for block 2. Now, the ID for block 3 is dependent on that 11567. So let's say block 3 has a hash ID of 25690. And block 4 has this hash ID, 78954. So all of these IDs that are created, let's call them IDs for the sake of this example, these Merkle roots, these IDs that are created are dependent on the previous one. So if I transact $5, just like in the previous example, but then I try to reuse that $5. And keep in mind that each one of these blocks being formed on the blockchain happen about every 10 minutes. So it's not infeasible for me to kind of just try to stick one in. Now, before block 3 had a hash ID of 25690, that was block 3. Block 4 has one of 78954. But as soon as I try to reuse this $5, the result is a completely different hash ID for block 4. Because block 4 originally with the 78954 was completely dependent on me using this $5 here with the different keys that are associated with my wallet that forms the different IDs up to here. But as soon as I try to reuse that, the network realizes, wait a second, this is false. This is a completely different hash ID that's being formed. So also keep in mind that every time these transactions are happening, it is broadcasted out to the entire network to see. So once the network sees that your block is different from their set of blocks, it will be rejected. So in review, every transaction that we make on this blockchain, a Bitcoin network, is recorded in a digital structure made of hashes and Merkle trees. Each block of Bitcoin's blockchain contains the Merkle root. Each transaction is broadcasted to the entire network. And if I try to trick the network by reusing a previous transaction, the new block created from the hash would be different than everyone else's. So this, in essence, this decentralized network, we don't need a centralized authority to check each of these transactions. Instead, we are relying on work. We're relying on the longest block, the consensus of the block of the network. We're relying on computation and encryption to be able to verify the network. And that's what makes it powerful. And another great conversation to have in the future is how is it that you can trick this Bitcoin network? And there's things like the 51% attack and some other things where we can really dive into, and that really helps you understand some of the weaknesses, potential weaknesses in the Bitcoin network. But I would posit that by saying the Bitcoin network has never had a problem with the double spend. And the only problems that you hear about with Bitcoin are centralized repositories, so exchanges so like I think it was Mount Gox or something, where these are centralized exchanges. These are actual companies that are utilizing Bitcoin and allowing people to trade on them. These have been hacked. But the actual Bitcoin blockchain, it's never been hacked. It's been untouched for the 10 years that it's been around. So that is basically the presentation that I gave at the meeting, and hopefully it's stayed high level overview. Didn't want to get too much in the weeds, but please watch Professor Evans. She has a wonderful presentation, and it goes along quite well with mine and talking about the blockchain and stuff. And so she kind of goes more in depth on, why we as lawyers should care about the blockchain. So watch that. We're happy to have you at our meetings and love to receive feedback about what we can do to make this a meaningful experience to be able to network and talk about blockchain and Bitcoin and these other cryptocurrencies. So thank you for watching and have a wonderful day.